Hello. Now here question is using binomial theorem expand x plus 3 raised to 5. So first let us see what is exactly binomial theorem. We know a plus b square plus 2ab plus b square. We know a plus b cube, a cube plus 3a square b plus 3ab square plus b cube. Now if we want suppose a plus b raised to 4 or a plus b raised to 5, how we can find? Like here we want x plus 3 raised to 5. So a plus b raised to 5, similar to that. So first observe these two. In this a plus b whole cube, first term is what? A cube. And last term is what? B cube. Okay. Then in second term a cube becomes like a square. Then next is a, that means a raised to 1. That means a is decreasing. A cube, a square, a raised to 1, and there is no a, that means we can say a raised to 0. So 3, 2, 1, 0. And b is decreasing from this side, that means b is increasing from this side. So here there is no b, b raised to 0, b raised to 1, b raised to 2, b raised to 3. So a cube, a raised to 2, a raised to 1, and a raised to 0. And here b raised to 0, b raised to 1, b raised to 2, b raised to 3. So when this here n is 3, number of terms are what? 1, 2, 3, 4. That means number of terms are n plus 1. 3 plus 1, 4 terms are there. Same here, 2 plus 1, there are 3 terms. Okay. And here a first term is a square and last term is b square. A is decreasing, a square, a raised to 1 and a raised to 0. B is increasing, b raised to 0, b raised to 1, b raised to 2. So same we can write here. Okay, a plus b raised to 5. First term we will get a raised to 4. In second term we will get a square, a cube. Then next term we will get a square. In next term a raised to 1 and then a raised to 0, that means no a. Now into b, here we can write b raised to 0 or that is 1. Here we can write b raised to 1b, here b raised to 2, here b raised to 3, and next term is what? B raised to 4. But see here in these two, here there are some multiples like 1, 2, 1. Here this is 1, 3, 3, 1. How we can find these multiples? Okay, so for that we can use Pascal's triangle. So what is that Pascal triangle? First write here 1, 1. In second row add this 1 plus 1, 2. Write here again 1, 1. In next row write 1 plus 2, write in next row, middle part, 1 plus 2, 3. Here 2 plus 1, 3. Here 1, 1. Okay, so now this is for n is equal to 1. This is for n is equal to 2. This is for n is equal to 3. That means what? For n is equal to 1, this is 1c0, 1c1, which is given in binomial theorem. And for n equal to 2, like here, this is 2c0, 2c1, 2c2. So these multiples are, see here, 1, 2, 1, 1, 2, 1. Okay. For n is equal to 3, this is 1, 3, 3, 1, 1, 3, 3, 1. So for 4, write here 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. Again write here 1, 1. So this is for n is equal to 4. So first multiple is 1, no need to write. Second multiple is 4, so write here 4. Third multiple is 6, so write here 6. Next multiple is 4, write here. Next multiple is 1, so no need to write. So expansion of a plus b raised to 4 is a raised to 4, 4a cube b, 6a square b square, 4ab cube and b raised to 4. Similarly we can find for a plus b raised to 5. Find out here next row. 1 plus 4, 5, right here, 6 plus 4, 10. So same. Now this is our binomial theorem. But roughly this is binomial theorem. Exactly let us see what is binomial theorem and then we will find x plus 3 raised to 5. Now a plus b raised to n is equal to, what is binomial theorem? First write nc0 in first term. In second term write nc1. These are actually that multiples. Okay, so nc0, nc1. In next term write NC2. In next term write NC3, and last term is NCN. We know what is NCR. From n elements, if we want to select R elements, then number of ways in which we select R elements from given n elements is NCR. And actually formula is n factorial upon R factorial into n minus R factorial. But this is the shortcut method by that Pascal's triangle, which we can use here. So here, now in first term NC0, write here into this first term A raised to this minus this n minus 0 n, and B raised to this 0. Now B raised to 0 is what? 1. Next NC1, write this first term A raised to n minus 1 and B raised to this 1. So in NC2, how we can write? A raised to n minus 2 and B raised to 2. Okay, then NC3, A raised to n minus 3, B raised to 3. Right, dot dot. So last term NCN, how we can write? A raised to n minus n0, B raised to n. Okay, this is B raised to n. So again A raised to 0 is 1. And always by that Pascal triangle, we know first term is 1, last term is 1. So always NC0 and NCN, they are equal to 1. So this is 1, this is 1. So we will get first term like that, A raised to n, like in that A plus B square, A plus B cube. And last term we will get this one, so B raised to n. So first term is A raised to n, last term is B raised to n, then A will decrease and B will increase. So this is our binomial theorem. Let us use here to find the x plus 3 raised to 5. Okay. So just applying this binomial theorem here. Now this is like A plus B raised to n. So here A is x, B is 3, raised to n is what? 5. So first we have to write phi c0. Okay. Then phi c1, phi c2, phi c3, phi c4 and phi c5. So 0 plus this 1, 2, 3, count these are total 5 plus 1, 6 terms. Now first A, that is x, raised to write 5 minus 0, 5, and second B, that is 3, raised to 0. Same here, first x raised to 5 minus 1, 4, and 3 raised to this 1. In third, x raised to 5 minus 2, 3, and 3 raised to 2. Here x raised to 5 minus 3, 2, and 3 raised to 3. Next, in phi c4, write x raised to 5 minus 4, 1, and 3 raised to 4. Next, phi c5 into x raised to 5 minus phi 0 and 3 raised to 5. Now we have to find this phi c0, phi c1, phi c2, phi c3, phi c4 and phi c5. So for that, use now again Pascal triangle. So we know that now. Right here 1 1, 1 plus 2, 1 1, 1 plus 2 3, 2 plus 1 3, 1 1, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4, 1 1. This is up to 4. So for 5, right next 1 plus 4 5, 6 plus 4 10, 6 plus 4 10, 4 plus 1 5, 1 1. So this is our phi c0, phi c1, phi c2, phi c3, phi c4 and phi c5. First is always 1, nc0, last ncn is always 1. So phi c0, this is 1 into x raised to 5, any number raised to 0 is 1. So 3 raised to 0, 1. You can write here bracket. Second term, phi c1, that is 5 into x raised to 4 into 3 raised to 1, that is 3. Next, phi c2, that is 10, x cube, 3 square, that is 9. Next, phi c3, again 10, this is 10 10, x square, 3 cube, that is what? 27, plus this 5c4. 5c4 is 5, x raised to 1x, 3 raised to 4, 3 square 9 into 9 81. Multiply 3 4 times, you will get 81. Plus last 5c5 is 1, x raised to 0 is 1 into 3 raised to 5. Okay, so now just simplify this and write the answer. So this is the answer, x raised to 5, 5 into 3 15, x raised to 4, 10 into 9 90, x cube, 10 into 27 that is 270, x square, 5 into 81 405 into x, and 3 raised to 5 is find out 243. Okay, now see this why we call Pascal triangle. Here we start with 1 1, but actually we can write here 1 also. For n is equal to what? 0. Then n equal to 1, 2, 3, 4, 5. So this is like triangle. Okay, this is like a triangle. So this is called as Pascal's triangle.